Last episode we found columns that repeat each other and drop the redundant ones. Now the opposite question of everything that's left, which columns actually help predict churn? Let's pack only what earns its place. 3 quick lenses for selection. Lens 1, variance. If a column barely changes across customers, it can't help separate churners from stayers, drop it. Lens 2, a univariate score. Take each feature on its own and ask how strongly it relates to churn. Select K best, ranks them and keeps the top K. Lens 3, model based importance. Let a tree model train, then ask which columns it actually split on the most. That captures combinations a one at a time test misses. The lenses won't agree perfectly, and that's fine. They answer slightly different questions. Where they agree, you can be confident. The non-negotiable, every one of them is fitted on train only. Let's score the numeric telco features against churn 3 ways and rank them. Spine first, load, fix total charges, encode churn to 0. And 1, split train and test stratified with random state 42. Variance threshold on the train numeric columns. See whether any column is near constant. Select K-best with the ANOVA F-test. Fit on train gives a univariate score per feature against churn. A random forest fit on train hands. Back its feature importances, a second opinion. Print both rankings. The figure draws both scores as horizontal bars so you can see where the lenses agree. Tenure and the charges columns rise to the top. That's stage 4 done, scaled, deduplicated, and trimmed to the columns that matter. Next stage, we stop doing these steps by hand and wire them into one reusable scikit-learn pipeline where leakage becomes structurally impossible. If this helped, like and subscribe for more.